So, welcome to the walkthrough for the Edexcel Higher. It's the summer of 2017 and we're on to paper 2, so calcs at the ready. So question 1, good old probability. As you'll know, sum of probabilities must add up to 1. So 1 minus all them, they add up to 0.69, means that is 0.31 in there. So it's saying 1 or a 3. So when you add the 1 and the 3 together, we get 0.49. And to estimate the number of times you'd expect something to happen, you multiply it by the number of trials, and out pops a 98 for 3 marks. Number 2, good old wordy, so keep it organised, try and make it as simple as possible. It's easy maths, but they are definitely trying to overcomplicate it. So what you've got, split it up. You've got adults on one side, you've got children, brag over CH because we've also got circle as well, and they're in the ratio of 5 to 2. So you can either have seats in the circle or seats in the stalls. So circle, stalls, circle, stalls. You're told 3/4 of the children had seats in the stalls. 117 were in the circle. So don't read on. There's your first bit of maths to do, because you know that those 117 account for 1/4 of the children. So times that by 4, you now know that there are 468 children in this particular arena, or is it theatre? Once you know that, we can go back up to here. Don't forget, when you're told a ratio, you're told a bit more than that. You're told fractions. You could call it 5/7 and 2/7. You could say, and I'll do it this way, that to go from 2 to 5, in other words, to go from children to adults, you have to times by 2.5. So there you go. Take the 468 times by 2.5. You know how many adults, but now not only do you know how many adults and children you've got, you now know how to work out the percentage of seats being used. So total seats being used is those two numbers added out of 2,600 in the theatre and times it by 100, we get 63%. Now, when you've done a lot of working out, always read the question, make sure you answer it. On Saturday, were there people on more than 60% of the seats? Bosh. So yes. Number 3, as you can see, I've done it already. Why? Because otherwise working with a jumbo crane takes me ages. As you can see though, I have lined them up because that helps confirm you get the height. 2 meters should be 4 centimeters, so 4 squares for the height. Width of the place from the side is 1, so you should be 2 squares wide. Height going up is 0.5, so it should be 1 square there and 1 square there. And the slope, well, you can't tell how tall it is from the slope. Could be really steep, could be quite shallow and not so steep. So you just have to realise that all you could see is the total height. So that comes into play there. And so would also have a total height of 4. On we go. Number 4, we've got Ollie going to Manchester, Sheffield, and all. What we else got? Liverpool, from Liverpool, and so on. So, as usual, these wordy questions, always remind yourself of the compound measures, distance, speed, time, or SOHCAHTOA if you're using it, or indeed density, mass, volume. Let's look at Liverpool to Manchester. The time it takes will be 56 kilometres divided by, and it takes him, he's travelling, the speed is 70 kilometres per hour. And that's going to spit out 4/5 or 0.8. But think for a second, 0.8 hours. All right, you might want to work in minutes, so times it by 60. It's your choice. That does now mean to work out the average speed, you do now know the total distance. So those two added together, that's 117. You also know that you've got 1, 2, 3 minutes because it's 75 minutes, 45 minutes. So 75 added to 48 is 123 minutes. I would go about this. I always think it's better that if you've got 123 minutes, if you divide that by 60, you can then just work straight in hours. So you could divide by 123 times by 60. Doesn't matter which order, no one cares. It's 57.1. On we go. Janie drove from Barnsley to York, etc. Now, if you read all that, whatever, at the end of the day, it's only worth 1 mark. All right. If Janie is correct, so the assumption is that she's right, you can just go between 80 and 60. So in other words, the average is 70. If she's correct, what does it tell you about the two parts of the journey? In your own words, time taken for each part must be the same. In other words, must be equal. On we go. Number 5, one of them with a diagram. Now, if you don't like overlapping triangles, feel free to draw a big one and a little one. It's entirely up to you. Sometimes I do it, sometimes I don't. This one's not the most complicated, so I won't bother. So the whole e to c is 8.1. The bit inside, that's why I put the 5.4 inside, making that bit 2.7. D to B is 2.6. Now, before I even read on, I think, well, if I start with DC, that's 5.4, how do I get ED? In other words, what's my multiplier? What's my scale factor? Well, you find your scale factor, do your end result, 8.1, divided by your starting point, 5.4. In other words, your multiplier for this question is 1.5. So if you want to get bigger, you times by it. And for part B, when you want to get smaller, you divide by it. So we need to work out the length of AE. AE is corresponding to the 2.6. So it's a times, and you get 3.9. AC is the other way round, so we're going to divide by 1.5, but when you get your answer of 4.1, don't forget A to C is 6.15. When we've divided by 1.5, it's that bit there, it's B to C we've just got. We want A to B. So we need to subtract. So 6.15, take away the 4.1, gives you the little tail end, 2.05. Must admit, I'm quite flummoxed. By coincidence, they've got 2.05 here and here. I think someone was got certain numbers fixed in their mind and when they were writing this paper, but there we go. On to number 6, bog standard calculated percentages. Personal bank. All right, you don't actually need to write that if you've separated it, but we've got a capital. 2% is a multiplier of 1.02, and it's 3 years. Stick that in your calc. You can either have your total, or you could subtract the 25 grand and find out how much the interest is, but it don't matter because they're still easy to compare. Here, same capital, but you're multiplying by 1.043 for 1 year and 1.009 for the remaining 2 years. And when you stick all that in, you get slightly more, £26,546.46. It says which bank is better. So it's Secure Bank. If you want to go a bit more detail, it pays more by £16. Whoa, not 28. £16.26 is the difference. You don't have to go that far once you've got those numbers. They're easy to compare. Just state the bank clearly. Question 7, I say it on every video. If it's rounded, it's up and down by half the rounding amount. 2 decimal places is nearest penny, so you need to go up and down by nearest half a penny. So if we go up and down, our lower bound is 4.755, which it can be equal to, and our upper bound is 4.765, which it can't. And as I said, you are allowed to use the 0.49 recurring on there, but I just think that's a waste of time. Number 8, dead easy. Put the lines on automatically because otherwise it'll take 2 minutes longer. 160, off you go. Draw to your line, draw over there, and as you can see, there's 12. That's it really. Not a lot more to say. Number 9 would take about 10 minutes more if I was doing this without. As you can see, I've simply chopped my model answers solutions off here. Nothing, it's 3 marks, but take your time. It's worth 5 minutes because it's easy. Just do one thing at a time. Get triangle B by reflecting in the x-axis. And then he reflects triangle B in the line y equals x. So it reflects over there. Do it by counting. Make sure, don't forget, when you reflect, it should be at a perpendicular. Always check that, particularly for diagonal lines. All right, but as I say, take time. Take 2 minutes for that. Don't rush it. Then Amy takes over. She reflects in the line y equals x. Well, that's already been plotted. So she goes to D. Now, as you can see, you could get confused because D to C is a reflection in the y-axis, but it's the x-axis to get E. So if you were trying to do it in your head, I wouldn't bother. If you're trying to do it by coordinate, just too complicated. Do it by just, it's a good revision question. It practices your transformations, obviously reflections. Good revision, just do it. And then you get quicker. All right. So is Amy correct? No. It says you must show how you get your answer. Well, nothing says it more clearly than actually doing it. So why would you not just do it? On to standard form. Greatest mass. So you look for the higher powers. You maybe know that Jupiter and Saturn are the 2 biggest, but Jupiter is the biggest by far, whether it's knowledge or by this table. Find the difference. Well, you've got a calculator. Difference means subtract the masses of Venus. So Venus, take away Mercury. Always do biggest, take away smallest. And your calc should say 4 points. It's only worth 1 mark. That's why you do it all in your calc. 4.5388 times 10 to the 24. Nishat says that Neptune is over 100 times further away. So I simply wrote down on my model answers the standard form for Venus, that's times 10 to the 7, and the standard form for Neptune, 4.35 times 10 to the power of 9. So you've got a choice. You could times Venus by 100 or divide Neptune by 100. That's what I did. In other words, 10 squared. Or in other words, take 2 away from the power. Or in other words, do it on your calc. As you can see, they're close, but it's still slightly bigger. So is Nishat right? It's a yes from me. Number 11, solve. So I just multiply through 4, 3 and 6 all go into 12. So let's take the first. If you multiply it by 12, it means you end up needing to multiply the top by 3 because the 4's already dealt with, because 12 is 4 times 3. So we get a 9x minus 6. I always separate it in brackets. We've got a 3 here, so we need to multiply the top by 4. And we've got a 6 here, so we need to double the top. I would collect my like terms. We've got 9x take away 8x. Negative 6 take away 20 is negative 26. On the right, we'll just ignore the brackets. Adding 2x to both sides, adding 26 to both sides. 28 over 3, 9.3 recurring, or 9 1/3. All will suffice. Number 12, the main thing that's wrong, again, in your own words, but the second student should have a denominator of 29 or words to that effect. And part B, have a read, it's very waffly. As always with these 1 markers, keep your answers simple. It's the plus that's wrong. When you go down a probability tree, it should be a multiply. So should work out that if you want to do it, feel free, but it's only worth 1 mark. Number 13, this histogram shows 134 people in a sport club. Some are male, some are female, some are over the age of 50. That's why I've put the blue line in. So 20%, I like to think of that as a fifth. All right, so over the age of 50, let's have a look. So in this area here, we have a width of 30 and a height of 0.7. So there are 21 people in that box or bar, whatever you want to call it. So we need to know how many people are here. How many are in the over 50 category? Well, fortunately, it's half of the bar. It's also got a width of 10, a height of 1.4. There are 14 people in there. So how many people over 50 do we have? We have 35 who are above 50. But a fifth of them are female. So a fifth of the 35 are female and over 50. A nice histograms question, in my opinion. There's definitely much worse. Now, when you look at number 14, worth just for, if you're using these papers to revise properly, you should be thinking out loud, what does each graph represent? This first one is the exponential graph. This one is, well, actually, it's the negative reciprocal graph because h is the positive reciprocal graph. C is the sine x because it's your trig graph that starts at 0 before going off on the roller coaster ride. D starts at 1. That makes it your cos x graph. E is the quadratic graph, but it's been moved down a bit. F is your cubic graph. G is your upside down x squared graph. And I is your exponential decay. So in other words, e to the minus x graph. All worth revising in their own time. No, they're not all likely. Sin x and cos x, x squared, x cubed graphs are more common, certainly, than your negative exponentials and so on, but well worth revising. So based on all that knowledge, I've already said that the one in C was the sin x. I said that F was a cubic, and it's the only cubic, so in it goes. I said that A was the exponential, e to the x, but they all have the same shape. Don't forget, e is just a number. So A could have been any number to the power of x. And then you've got the positive reciprocal graph. The fact that there's a 4 there, who cares? It's rarely the graph of 1 over x. Because the 4 just changes the scale slightly. Well, there is no scale. So that's just a h in there. But use those questions to revise from, and you'll really help your knowledge for the exam. Anyway, number 15. Like I always do with these proof questions, I have written out the model answers, the perfect, well, quote unquote perfect answers. Certainly the way it's set out is in the way that the examiners want to see. So go to my website and look up the model answers. I'll just talk you through it here. So the idea is you've basically got a lot of this going on. That angle equals that angle, and so on. And the reason you give for them is angles in the same segment are equal. So prove that ABE, that's that there, is equal to DCE. Now, I know they look like it, but you can't assume. So you should argue that BAE, so this angle there, and that angle there, they are equal because they are angles in the same segment, just like ABE and ECD. If you just mirror image that, they're the same segment, they're the same segment. So for the same reason, those angles on the right-hand side are equal. Then you've got these, that angle there is equal to that angle there, because opposite angles are equal, or if you want to be perfect, vertically opposite angles are equal. In other words, you've got angle, angle, angle. And that, if all angles are the same, there's no way you can show that the sides are the same length unless you've got a bit more info. But angle, angle, angle is enough to justify that they must be similar. Because don't forget what similar means. Similar means same angles, but could have a scale factor for the sides. So it's enough that all the angles are the same. Number 16, using algebra. So it's a doubler. All right, I'll do that difficult one first. Let x equal 0.136, and it's them that recurs. So budge them all up, because in all these questions, you want the recurring to be straight after the decimal point. Now, if I wanted to budge them up again so that it has the same, I need to times right by 100 and left by 100. In other words, I get 1000x on the left-hand side. Now we do a big takeaway. So we get 990x is 136, take away 1. The recurrings cancel. And obviously this is where your calculator helps out, because that simplifies to 3 over 22. I know it says using algebra, so you'd show the algebra, but you're on a calc paper. It doesn't say you have to, show every single step. You do if you have to get to you do show a bit of cancelling now and again, but because it's only 3 marks, no, I wouldn't bother. Don't go going down to, what is it, 27 over 198? Forget that. Now on to the easy bit. Different letter for 0.2 recurring. Why is it easy? Because it's just a 1 decimal place job. And when you take them away, 9y is 2. Oh, come on, Al. So y, got good habits there, bad habits, whatever you want to call it. So y is 2/9. So now it wants us to multiply them. So 3 over 22 times by 2/9. You could go straight for it, but I'll pre-cancel. Divide the top by 3, bottom by 3, divide top by 2, bottom by 2, and guess what we get? 1 over 33, thankfully. Next. Number 17, strange little question here. So you've got to read the words, because in the words it tells you that the radius of the sector is 11. Bosh. And it tells you this is equilateral. Now that fact is telling you a little bit more than all these sides are 7. It's also telling you the angle inside is 60. So we're not only dealing with an equilateral triangle, we're dealing with a sector that is a sixth of a circle. So now you can crack on. Let's do the sector as a whole. So the sector as a whole is pi times the radius squared, but it's a sixth of a circle, so it's over 6. Now it wants the final answer to 1 decimal place, but most calcs nowadays will work in multiples of pi, so let's leave it like that. Now let's do the area of our triangle. So it's non-right angled, so it's half AB sine C, or in other words, a half times A and B, which is 7 and 7, which is 49, times sine 60, root 3 over 2, etc. in other words. But you've got your calc, so your calc will spit out 49 root 3 over 4. So when I do triangle divided by whole thing, when I do 49 root 3 over 4, it divided by the whole shebang, don't forget that will give me the percentage unshaded. So the percentage unshaded is the amount which is not shaded divided by the total area. Be careful with your calcs, stick extra brackets in if you need, but when you times it by 100, you should get 33.5 etc. %, which, if you take that away from 100, it means the amount shaded is 66.5. Now you could have argued, why did I not subtract them and do 121 pi over 6 minus all that? Because then you'd have got a horrible number and you'd still have to have used this formula anyway. So I actually think doing 100 minus that was the easier bit to minus. So just personal preference, but either way, no one really cares as long as you got 66.5, because 1 dp is what it asked for. Number 18, laws of indices. Now, even though you've got a calculator, good practice just to do it without, in my opinion. So 16 to the power of a fifth, 2 to the power of x, 8. The link is they are all powers of 2. So 16 is 2 to the power of 4. 2 is already in the 2 form. 8, though, is 2 cubed to the power of 3/4. Let's apply laws of indices. Power to a power, in other words, brackets, means multiply your powers. So here, 4 times a fifth. No, so you could use decimals at this point. You've got a calc. It's entirely up to you. I'm just choosing to revise non-calc. And here, 3 times 3/4, 9/4. And there you go. Because when you multiply, it means add your powers. So 4/5 added to x will give you 9/4. And again, if you want to practice, feel free to convert them into 20ths. This is where I picked up my calc. 9/4, take away 4/5, gives me 29 over 20, or 1.45. Either, obviously, 1 and 9/20ths, all perfectly good answers. Number 19, long-winded algebra. So if we want to write them all over x minus 3, x plus 3, because that is indeed the lowest common multiple of 1, x minus 3, and x plus 3. So all three terms need to be multiplied by x minus 3, x plus 3. So the first term, it's just a 2 times those brackets. Now, it is kind of a show question, so it's not quite a fully show question, but I wouldn't be multiplying these out in my head. Too many things can go wrong, and there are minuses flying all over the place, so I'd take it steady myself. X plus 3. And then the next bracket has a minus in front of it. That's what I'm on about. Now, when we multiply the middle term by x minus 3, they cancel. So we just end up multiplying the top by x plus 3. And again, there's another negative. And when we times by x plus 3, they cancel. So it's just a minus 3. Now the bottom, we can expand it. We know it's coming. It's difference of 2 squares. That's the least of our worries. It's what goes on top that we need to take care with. So I'm going to expand these brackets, doing it mentally with loops, but don't forget to double it. So x times x doubled. Negative 3 times positive 3 doubled. The minus 3x, the plus 3x cancel out. No need to worry. Now when you expand these brackets, again, I'm not drawing the loops, I'm doing them mentally, but don't forget, people, we're timesing it by the minus. So x times x is x squared, but it's a minus. 2 times 3 is 6, but it's a minus. 2x, 3x, but they are minuses. Same over here, expand the brackets, but don't forget about that one. So x times x, x squared. Now we know we're heading in the right direction, because look at the question. There are no x squareds in what you're being asked to show. And nicely, they all disappear. So as I said, That's a confidence builder. You know you've hit the mark. You know you're heading towards at least 2, if not a guaranteed 3, even with a mistake or so. Anyway, -6 times -3 is positive 18, but it's a minus because of him or her. -6x minus 3x is -9x plus 9x. And now we just tidy up what's on top. So x terms, I've got -5x plus 9x gives me 4x. So a is 4. Then I've got -18. -6 is -22. -24, sorry. -18 takes me to -42. And that's my value of B. They're great, them questions, in terms of you just going through the motions, but definitely want to practice. They come up almost every year. Number 20, as you can tell, I've cheated because using my electronic pen does not help accuracy at all. It's like doing it with a crayon. So let me explain A to begin with. What does it mean by suitable straight line graph? Al, why have you drawn the graph of y equals x plus 4? Here's why. Looking at this and looking at this, how do I turn into what I'm given? How do I turn it? Well, no, not 3xl. We started with a -2x. How do I turn the top one into the bottom one? As you may see, -3x has had an x added to it. So add x to both sides. The -1 on the end has been turned into +3. How does that happen? We add 4 to both sides. And that, folks, is why I drew the graph of y equals x plus 4. So I popped on the intercept and gradient of 1, so along 2 up 2, along 2 up 2. And then estimates of the solutions. You read the points off the graph. Have a look where they intersect. All right, so you're reading off those values down there. The perfect answers are -0.3 and 3.3, and the mark scheme allows you to be plus or minus 0.1 out. So a little square either side. Or is it half a little square? Yeah, because it's 0 to 2. So it's half a square out. Then they say estimate the gradient. So as you can see, again, I've done it on, this is how I've done it properly on my model answers. So again, check them out if you want to see exactly how I set these out. But as you can see, draw your tangent on, try not to go inside the curve, try and make it a fairly good sized triangle, not too small. Bigger than you can certainly make them bigger, but don't make them small. I read off the height of my triangle. I estimate the height to be about 5.5. I estimate its width to be about 2.6, and I get an approximate answer of 2.1. Mark scheme's very generous on this. They allow 1.6 to 2.5. So what's the perfect answer? 2.05 or something like that? Hey, that's the answer they're fixated on, if you've been listening for the earlier bits. Number 21. So, how do we work out the area of a rectangle? Well, it's length times height. Well, the width of this rectangle, or this distance along here, is really easy. because you're told the radius of each circle is 24. So that's 1, 2, 3, 4 lots. So it's 96 wide. So we're going to need to do 96 times something. What is that something? Well, that something is this distance here. Part of that something is 24. That's because that's the radius. Another part of that something is also 24. The problem here is we don't know the bit in between, but you can make a triangle inside. Okay, what's even more important is that's the radius, so that is 48. So is that. So is that. And to carry on this examiner's love of keeping themes throughout, we have another 60-degree angle like we did on an earlier question. It's equilateral. But what are we after? Well, if we just draw half of that, that's 48. That is 60. If we work out that distance there, that refers to that distance there. So it's that distance we are after. I'm going to call it x. Okay, so how do I find that distance? Oh, hold on, I could use trigonometry, all right, because of the angle. I could use Pythagoras, because actually that's 24. So it doesn't matter which way you go about it, as long as you get x. The quicker way is I'm going to use Pythagoras, so I can say that x is the hypotenuse squared minus the shorter side squared, all square rooted. Calc says 24 root 3. So bringing all the pieces of the puzzle together to find the area, the distance across was 96. The vertical distance, the height, if you want to call it that, is 2 24s plus the bit in between that we just found. Bearing in mind, it wants 3 significant figures. What did I get? 8,598.6 and so on. 8,059 rounds up, so 8,600 for 3 sig figs. On we go for a pretty bog standard nth term. So you look at your first differences, we get 7, 11, 15 and 19. So your second differences are 4. And as your teacher will have nagged you, you halve that, because that's the number that becomes the coefficient of n squared. Then you have a look at what your 2n squared sequence looks like. In other words, square numbers doubled. So 2, 8, 18, 32 could carry on but can't be bothered. Always work out your sequence, take away what you've just done. So 4 take away 2, 11 take away 8, 22 take away 18. And if you're not spotting a pattern by now, all right, so we've got 37 take away 32. If you can't see a more friendly pattern by now, you have messed something up. You need to have a rethink of your technique, maybe have a restart, all right? But now you do a reset. Now you need to work out the nth term of these numbers. Well, they're going up in ones, so it's a 1n. And my 1n times table looks like that. And it's 1 above. Obviously, you don't need the 1 next to the n. And why did I bother doing when it's so easy at the last stage? Why didn't I just write down n plus 1 when it was so obvious? Well, to some people it's always obvious, but I'm just saying if this was less obvious, could even be coming down in certain things. If it was less obvious, well, you've still got the technique mastered. On we go. So, final question. I'll be honest, not as bad as it looks. They're just trying to catch you out by mixing up circles and radicals or square roots. So as soon as I see the top line, whether I need it or not, I always make a note of the centre and the radius. Why would you not? So we know that if you were to draw it, the centre to a point, how do we find the radius? It's the vertical over the horizontal. It's the y's, changing y's over changing x's. In other words, gradient of the radius changing y's is root 7 over 2, take away naught, divided by 3 over 2, take away naught. Feel free to stick it in your calculator, but you don't need one. It's root 7 over 3. Just leave it like that. Don't need a decimal. And don't forget, that's the that's the radius gradient. What about the gradient of the tangent? It's the perpendicular. It's the negative reciprocal. Change the sign and flip. So you've now got the x and y coordinates. You've also got the gradient. You can either y equals mx plus c it, or use y minus y1 equals m into x minus x1. I'm going to do that one, just because on my previous video I did y equals mx plus c. So y minus the y coordinate equals the weird gradient into the x coordinate. What is it? 3 over 2. Now here's the thing. I've read the mark scheme. You can leave it like that. It says find an equation. It doesn't ask you to put it in a particular form. I mean, it shouldn't take you much to put it in a particular form because you've got a calc. So if you wanted to, times those brackets out. Oh, that second loop looks a bit hard. No, it's not. It's just 9 over 2 root 7 and so on. And you've got your calc. And most calcs nowadays will work in third form. And obviously then you can add the root 7 over root 2 to it. So the fact it's on a calculator paper, it would be easy. In fact, just in case you did, the alternative answer, is 3x over root 7 plus 8 over root 7. Or in other words, you could take the 1 over root 7 out. So you could spend a bit of time, or in other words, waste a bit of time turning it into that. Me, I'm not bothering. I'm going to leave it like that because that's one of the possible answers given in the mark scheme. So do not overcomplicate them. You've done plenty of work to that. It's only worth 3 marks. Anyway, hope you enjoyed that. Hope it's helped a lot. See you on the next one.